It's also my pleasure to welcome today's presenter, Roberta DeBay, postdoctoral research fellow at the University of Adelaide. In this webinar, Roberta will discuss an online application developed by the University of Adelaide researchers to monitor grapevine canopy size. Before I hand over to Roberta, I have a couple of quick points as to what to expect for those who are new to AWRI webinars. The format for today is a short presentation followed by a Q&A. The webinar is being recorded and will be available to view via the AWRI website. It's important to remember that webinars are interactive and that there are a number of ways to get involved. To ask a question, please type into the questions section of your control panel in the bottom right corner of your screen. For those with access to a microphone, there is also the option of speaking directly with our presenter by clicking the Raise Hand button. This is located in the top left section of your control panel. Please feel free to send through questions at any time, as well as during the Q&A session, and I will get as many questions through to Roberta as possible. Finally, if you'd like to get involved through Twitter, please use the Twitter handle @the_AWRI. Okay, that's enough from me now, and I'm going to hand over to Roberta to tell us more about today's topic.
Thanks to the AWRI for inviting me to give this seminar today and to you for registering to attend it. What I would like to show you today is this VitiCanopy app, show you how to use it, it's being calibrated, how to interpret the results, and some applications to vineyard management. I will start with a brief introduction and some of the definitions of the main concepts we will be talking about today. So first of all, let's make it clear what canopy management is. And we call canopy management the series of techniques applied to grapevine to modify the amount and distribution of the leaves, shoots, and fruit in the canopy. There are many reasons why we apply canopy management, but commonly is used to open up dense canopies with the final aim to achieve vine balance. What is vine balance? There's heaps of definitions on the internet and in the literature, and the one I like the most is this one. So it says that a vine is balanced when it's in equilibrium between vegetative growth and yield, and that equilibrium lets you achieve the highest possible fruit quality for the target wine style. For example, this canopy that you see on the screen, it might look out of balance. However, I can assure you that this canopy is perfect for the wine style it produces. That is a cheap sparkling wine. So you see, vine balance is a bit of a broad term. There are many ways we can measure or look at vine balance. I'm sure we've all been in a vineyard and commented on whether we thought the vines were balanced or not, just looking at things like the ones that are listed here. So maybe internal length, were they too long or too short, if there is still growth after veraison, if there were green shoots, too much crop, and so on. Clearly these are all too subjective and just visual assessments. There are other ways, and the most common that you'll find reported in the literature are these vine balance indicators as the ratio of leaf area to yield or yield to pruning weight. The optima for these two indicators that you will find in the literature is normally 0.6 to 2 for leaf area to yield and 5 to 12 for yield to pruning. So you see there's some issues here because these indices are the range is too wide and you almost always fit in the balance category. And also they're that wide because they vary between site, variety, the training system, the climate of the area. Also many of these studies that report on vine balance indices, they do not relate the number they get to a measure of quality, and only in 1 or 2 cases they report a measure of wine quality. One of the other things that make them not that widely used is that the difficulty in measuring them. So to measure vine balance indices, you either invest a lot of time in collecting single vines, yield, pruning weight, leaf area, or you rely on scorecards that, again, they've been proposed almost 20 years ago, and they're based on a visual assessment, and so they are subjective in the assessment. Nowadays, we have a lot of possibilities with computers and image analysis, remote sensing, and this is where this VitiCanopy came as an idea to develop, because it's based on image analysis. VitiCanopy, like most of the other instruments that are available on the market to measure canopy structure, does not really measure the total leaf area per plant, but it measures an index that we always refer to as the leaf area index, which is defined as the total area of leaf tissue per unit of ground surface area. Being more precise, because VitiCanopy does not distinguish between leaves and the other components of the canopy from the image, what it really measures is a plant area index, so it's the sum of leaf area index plus the shoots, fruit, cordon, and so on. So whoever uses it needs to keep that in mind. It's not just green leaves. VitiCanopy bases the analysis on the cover photography method, which has been used as a reliable method in forests for a long time. It's used to measure canopy growth and biomass accumulations. The method consists in taking a photo of a tree canopy from the ground with the camera facing up, so that the sky is the contrast. And this image that you see on the top right corner of your screen is an example. There are then specific softwares that will analyze the image by dividing it down into multiple sub-images and filtering it into a monochrome image. Per each of these sub-images, the number of pixels and total pixels and the pixels in large caps, that are basically where the sky is, are counted, and by applying these formulas that you see here and these ones, the leaf area index is then calculated at the end. One of the critical parameters here is this K factor. There is the light extinction coefficient. So it's been demonstrated that their value for grapevine is 0.7, and this is the default one you find in VitiCanopy. It can be adjusted depending on the canopy size and also depending on whether you want to use the app on a different tree. So what we did in our group was, first of all, we adapted the method to grapevine, and we developed a custom MATLAB code, and you see in the paper at the top. However, we felt like there was still a wall between academia and the real world, because most people cannot use MATLAB or won't even know what it is. So that's how we came up with the idea of developing something more user-friendly, and VitiCanopy was developed that way, and everything you need to know about VitiCanopy is published in this paper in Sensors. There is also open access, so anyone can download it. I would just like to show you quickly how the app works with just a couple of slides. So this is the icon you'll see on your phone when you download it. And when opening the app, you are presented with a home page, and at the bottom you see 5 icons. In these icons you have you can tap on how to use, and there you have a little menu, and there's also an about page that contains a bit of information on how to use the app and about the developing team. The sorry, that one. Okay, the settings menu allows the user to enable the GPS on your phone. So in this case, if you have it enabled, every photo you take with VitiCanopy will be geotagged, so you can go back to the same spot and take more pictures, or just it can be used for mapping your data. The new menu allows you to take a photo or choose a photo from files and go through all the analysis steps. Once a photo is taken or chosen from files, it will be displayed in black and white, and this is where you can assess whether your photo is good enough for analysis and whether the app is being filtering correctly between sky and canopy. If the photo is good, by pressing done on the top right corner, the image is processed, and you'll have a pop-up result menu, and you can also go to the results page, tap on one of the files, and open up the complete results tab. As I said before, the results include GPS coordinates, and you can see a map of exactly where that image was taken. All the results in the tab can be then exported as an Excel file to a nominated email account, and you have your file ready for analysis. And now, just like to show you how this app was calibrated, so you can see that it works properly on measuring leaf area. So one of the most important activities was this calibration process. For that, I selected 20 vines. I set the camera at 5 distances from the cordon and took images after different levels of defoliations, as you see on the series of images on the top. And I ended up leaving only the bare cordon. Also, in this slide, you see the influence of the distance from the cordon on the amount of cordon you can see included in that image. This was obtained using an iPad 4, which has a field of view of 43 degrees, and most of the Apple devices have a very similar camera. The R-square in this table refers to the coefficient of determination of the equation obtained by correlating the measurements of leaf area obtained with VitiCanopy to the real one obtained by destructively collecting the leaves. This was all obtained using a common K of 0.7, as I said before, and you can see that the best models are those obtained when the images are taken between 70 and 80 centimeters, and this is the distance we normally recommend to take the images at. And these are the results we obtained from the calibration. So in the first graph is a correlation between the real leaf area and the one obtained with VitiCanopy. And you see how tight the relationship is. Even better is the graph on your right, where the validation is obtained by correlating with the results obtained from the Lycor 2000, which is the commercial instrument to measure leaf area index, and this it costs about $20,000. So you see again, the measurements are the same between the two instruments. And these are just a few examples as a reference to see or get used to what a good image looks like and what the bad images are. So these are two images that are just perfect for analysis with VitiCanopy. However, like in this case, VitiCanopy is not that perfect, and it works really well in VSP canopies, but when you move to a different training system, it might need a bit of a trial and might need a bit of change of the protocol. For example, in this photo, the canopy is fairly big and it does not fit in the image. In this case, VitiCanopy will saturate at about 4 or 5 of leaf area index, which means it won't be able to measure the whole canopy. One option in this case is to take the image of only half of the canopy and then double up the number, or measure the graph in another image. This is a really good example of a really bad picture. So this, I think everything that can go wrong is in here. The cordon is not in the middle of the photo. There's a wire on top of the camera. There's sunlight coming through. There's a weed. So these are absolutely not acceptable. Like VitiCanopy will give you a result anyway, but it's up to you deciding whether you want to accept a result of this kind. Similar thing, it can be tricky at certain times of the day not to have the sunlight in the image. If you get images like this, sometimes the app will give you error message, but sometimes it will give you a result. And again, it's up to you deciding whether you want to take that result or not, but it will be really biased by the wrong filtering. These people laugh at it, but it happens a lot. You look at where the image you want to take and your head ends in the image. This is a bit extreme, but it happens quite often, so that's another thing that you got to be careful too. This seems okay, but again, it was probably taken at a weird angle, and you see there's a bit of portion of the trunk in the image, so you'll get again a biased result if you take it for good. Now I'd like to just show you quickly some of the results on how to use VitiCanopy for management. For example, here I have measure images taken before and after shoot thinning. This comes from my trial at the Wade campus, where I apply shoot thinning by removing 50% of the shoots before flowering. What I do is just counting the total number of shoots and get rid of exactly 50. You see the results from VitiCanopy at the bottom. You see that by getting rid of 50% of the shoots, I reduced the plant array index by almost 40%. And you see the porosity was 0.2 in this photo and is up to 0.35 almost in this next one. You might think that this was this way just because it was early in the season, but actually that difference in canopy was maintained throughout the season. And you see at Verizon, the shoot thinning treatment was still the one with the smallest canopy compared to the control, and the porosity was the highest again compared to the control. What's interesting is that when I did the same in a commercial vineyard where I did shoot thinning by applying the industry SOP, you can see that the before and after shots are basically identical. And in fact, when I measure leaf array index and porosity of these two images, there's not a big variation. Again, you might say, well, the effect maybe was not big because it was early in the season, but I measured leaf area for control in blue and shoot thinning in red at ESL 15, average and harvest, and you see there's no difference in canopy size. So what I'm saying here is I don't want to say that shoot thinning is not needed, but maybe in this particular case or in this particular season, it might have been a bit of a waste of time doing shoot thinning in the whole vineyard, seeing the results that we got here. Another interesting use can be assessing the growth rate of your canopy. In this graph, you have the leaf area in the control in blue, double nodes in red, and shoot thinning in green. You see the shoot thinning starts very low because I did a treatment just before flowering. It reaches a maximum average and then declines a little bit towards harvest. And in the histogram here, you can see the growth rate between the different phenological stages. Just an example of what can be achieved using this kind of measurements, I correlated the growth rate from veraison to harvest to the citrus and tropical flavor perceived in the wines during the sensory analysis, and you see the relationship at the top here. So it's quite tight. Even better, when I correlated the same growth rate, so this one reported here, to the pH of the harvested grapes, you see how tight the relationship. So the more your canopy grew in that period, veraison to harvest, the higher was the pH in the grapes. And these are just two of many other examples that I could have put together for in this case. This is quite interesting. So I mapped the distribution of leaf array index in my trial in a Semillon vineyard, and then I used the relationship to that I obtained from berry sensory analysis to create a map of the berry acidity. So this is just liver index, and you see the smaller canopies are at the top here, and more vigour is at the bottom of this image. And when you use the relationship between the two to map berry acidity, you see how different that was in the vineyard. And this is important for a grower to know, because you might decide to harvest in 2 different times, or maybe allocate half of the vineyard to a certain product and the other half to a different one. Also, the same way you can calculate the crop coefficient that is used in water balance measurements to assess the amount of irrigation or the requirements of your vineyard. And again, you see that the requirements were higher where the canopies were bigger. So that's another way you can use the results you get from the app. In exploring the link between vine balance indicators and wine quality and whether VitiCanopy can be used to measure vine balance, I have to say that, as expected, vine balance was very different depending on the variety and the location. For example, here you have 4 vineyards in 4 different regions. They're all Shiraz, and you see how variable the different indices are. However, when relating those indices to wine sensory attributes, you can see that, for example, here is the likability of the wines, and here the wine balance indices. Those coming from vines with lower values of the vine balance indices are the most liked, and the same in McLaren Vale. So they like most the wines coming from lower values of the indices. Basically done. I'll just point out a few take-home messages. So let's say that as images should be taken early in the season, maybe flowering and veraison. We've seen so far that the best correlations with quality parameters are coming from measurements done early in the season, and it's also important to do so because then you have time to react if the canopy is not what you want, and you can apply management based on that. I always get asked whether how many images you should take per vineyard, and that really depends on the uniformity of your vineyard. I've had one of the students in the lab where I work is doing a master's on using VitiCanopy as part of a series of other measurements to assess grape quality, and he's seen that with 6 images per vineyard is getting already good results. Also, it's important that images and the results you obtain are kept so you can create a history of your site. As I showed in this presentation, VitiCanopy can be used to assess the practices that you are applying in your vineyard. The results can be used to build relationships between canopy size and quality. It can be used to benchmark vineyard regions or seasons, and also you've seen the mapping possibilities. Nowadays there are a lot of mapping tools available for free on the internet, so it's really getting a lot easier. Thanks for listening, and I would like to acknowledge the people that have contributed to this work. So my colleagues at the University of Adelaide, Cass Collins, Matt Gillingham, and Professor Steve Tyerman, Sigfredo Fuentes from the University of Melbourne. I'd like to acknowledge Treasury Wine Estates because most of the trials are conducted in their vineyards, our PhD and master students in the lab, and DJ's growers for the collaboration as well. Thanks again for listening, and if you have any questions, maybe not, if they don't come today, maybe later, you can email me at vinebalance@adelaide.edu.au or roberta@adelaide.edu.au. Thank you.
Okay, just as a reminder, to ask a question, please type into the questions section of your control panel in the right corner of your screen. For those of you with access to a microphone, there is also the option of speaking directly with our presenter by clicking the Raise Hand button. This is located in the top left section of your control panel. So we've got a question from Peter Riley. I'm just about to unmute your microphone. So you can go
Thanks
ahead.
for that, thank you, Roberta, for your interesting presentation. I was just picking up on the point that VitiCanopy wasn't seeing a great difference between canopies that had already been worked over, like before and after standard operating procedures for canopy management.
Yeah.
Would it be a better approach to actually take that picture horizontally through the canopy? Certainly we would be removing leaves that are down, shielding those grapevines, shielding the bunches, so that we're getting better spray penetration. We'd take them off on the eastern side so that we get morning sun on the fruit.
Yeah.
But
yeah.
we want that canopy above in the middle of the day and in the western sun as well. So if you took it horizontally through with somebody holding some sort of backboard, would that be a better approach or a possible approach?
That's been talked a few times, and it will be probably a good approach, but the problem is that you can't standardize it, because you can't decide on a distance from the canopy, and you can't have the sky as a contrast. I agree with you, like for measuring porosity it would be the best, but it would be difficult. We tried and we are still trying. Maybe eventually we get somewhere, but it's just a little bit difficult to make it a standard procedure.
You couldn't use a screen behind it or backboard, you know, a bit of white sheet?
Yeah, that's an option, but how many people will use it that way? Because it gets quite, you need to be at least 3 people, someone holding the screen at the back. We've done it all, like I've done it with sheets at the back, and I know it would be a really great option. It's just for now we haven't been able to make it standard and get good results out of it.
Yeah, okay. Thank you.
Thanks. Sorry. Okay, I have a question from Chris Brody. So is the app available for Android? And the answer is yes and no. So it is developed, it's ready to go. We're just having issues with the university to get access to the Google store to upload the app. It'll be out in no time, I reckon a couple of weeks. Again from Chris, how many images do you need to generate the maps? In that particular case, it was, because it's a research trial, it was a bit intensive. It was about, it was an image per panel. So let's say maybe 50 in 4 rows. Another question, so for canopies which struggle to fit into the camera window, is there any work being done to use a fisheye lens or other means to fit the canopy into the camera view? Yes, there is. It's part of this next season work, trying to calibrate a bigger field of view camera. So try to fit a whole canopy in there. The thing is that if you want precise numbers, like if you want to make sure that the numbers you get are the real number, you need to use the camera I've said. But if you just want to benchmark your vineyard or know whether treatments you're doing are different or so on, you can analyze any images taken with any device. As long as you keep your method standard, so you use the same camera at the same distance in all the images you take, you will get numbers that will let you compare between vineyards and treatments and varieties, anything you need. So if you want to analyze a fisheye image, you can already.
Don't seem to be any more questions coming through, so thank you, Roberta, for presenting today, and thank you also to everyone who attended and took part in today's session. For attendees, you will receive a follow-up email with a link to this recording and a link to the survey. The next AWRI webinar is on the 22nd of September, when Jeff Baldock from the CSIRO will present Optimising the Management of Soils and Organic Matter, the role of soil carbon in drought resilience. If you would like to register for this webinar, please visit the AWRI website. That's all we have for today, and thank you for attending, and we look forward to seeing you again next week at the next AWRI webinar.